All right, let's jump right in. We're going to talk about something pretty amazing today, the spot where artificial intelligence meets andrology. Andrology, if you're not familiar, is all about male health, especially fertility. And we're about to see how AI is set to completely reshape this incredibly human, incredibly complex field. Just imagine that for a second. What if a machine could see what our eyes can't? What if it could spot tiny patterns, subtle details, things that are totally invisible even to the most skilled specialist? Well, here's the thing. That's not science fiction anymore. It's happening right now. This massive technological leap is basically giving doctors a brand new, superpowered lens to look at male infertility. And believe me, it is changing the game. So, to really get why AI is such a big deal here, we first have to understand the problem it's trying to solve. And that problem, at its core, is all about the natural limits of the human eye when it comes to diagnosing male infertility. For decades, the absolute cornerstone of fertility testing has been semen analysis. And the old way? Well, it depends on a person looking through a microscope. That makes it subjective. I mean, two different lab techs can literally get two different results from the exact same sample. It's slow, it's tedious, but the new way, the AI-powered way, it's the polar opposite. It's objective, it's fast, and you get the same reliable result every single time. And this isn't some minor issue, you know? The source material we're looking at puts it perfectly. This subjectivity, this room for human error, it can directly affect a patient's diagnosis and their entire treatment plan. That is the fundamental problem that AI is here to solve. And make no mistake, this area is absolutely exploding. This chart says it all. I mean, look, AI and healthcare in general, that's huge, thousands of publications. But check out the bar for AI and andrology. It's a recent, super steep surge. We are literally watching a new frontier of medicine being born right before our eyes. So what is this AI that we keep throwing around? Let's quickly break down the core tech, not as boring lines of code, but as really cool new superpowers for doctors and scientists. First up, you've got machine learning. The best way to think about this is like training a superhuman assistant. You don't give it a bunch of rules, you just show it tons and tons of data, like thousands of images of sperm, and it just learns. It starts to see complex patterns all by itself, learning from experience way faster than any human possibly could. Then, building on top of that, you have neural networks and deep learning. Think of these as an even more advanced version, inspired by the way our own brains are wired. Deep learning uses tons of layers of these networks to solve incredibly tricky problems, like picking out one perfectly healthy sperm cell from millions of others. And this here illustrates one of the simplest but most powerful AI tools out there, the decision tree. Honestly, it's just a high-tech game of 20 questions. The AI starts with a big question, and then based on the data, it asks a series of yes or no questions, going down different branches until, bam, it lands on a final prediction. It's a really smart way for AI to help support a doctor's decisions. Okay, so now that we have these powerful tools, let's see how they're being put to work on that crucial fertility test we talked about, the semen analysis happening in the lab. The goal here is really simple. It's to take all that guesswork, all that subjectivity, and just toss it right out the window. The mission is to replace that old manual process with a system that is totally objective, incredibly reliable, and ridiculously fast. So, how does it actually learn? Well, it's a pretty cool three-step process. First, you just feed the algorithm a gigantic data set, thousands and thousands of sperm images. Second, the AI starts crunching, finding all of these key patterns related to how they move, their shape, even the health of their DNA. And finally, once it's trained, the model can look at brand new sperm it's never seen before and classify them with incredible speed and accuracy. And the level of detail we're talking about here is just astounding. It's not just counting sperm, it's analyzing their motility, how they swim. It's looking at their morphology, their exact shape. It can even measure something called sperm DNA fragmentation, which tells you how healthy the genetic material inside is. This is a level of detail that was just physically impossible before now. But here's where it gets really exciting. This technology isn't just staying locked up in the lab. Oh no, it is quickly moving into the clinic, and it's starting to directly help doctors with diagnosis, with analyzing images, and even with surgery itself. One of the most powerful examples of this is a field called radiomics. It sounds complicated, I know, but the idea is actually super simple. It's where AI looks at medical images, like an ultrasound or an MRI, and pulls out massive amounts of data that are totally invisible to the human eye. It turns a quick visual check into hard, measurable data, which makes diagnoses way more precise. And that is just scratching the surface. AI is basically becoming the doctor's co-pilot. It's helping predict how successful a sperm retrieval surgery might be. It's making MRIs more accurate. It's even using augmented reality to project images right onto the patient to help guide a surgeon's hands in real time. It's incredible. So where is all of this headed? Well, like any big, powerful new technology, the road ahead is full of incredible promise, for sure. But there are also some very real-world hurdles that we still have to figure out. This SWOT analysis from the source material really spells it out. The strength is obvious: less human error, more accuracy. The opportunity? To create brand new global standards for fertility testing. But there are weaknesses, like needing way more diverse data to train these AI models. And there are threats too, like the high cost of getting this tech into clinics and making sure doctors are actually trained to use it right. So what are the big takeaways here? Let's boil it down. Number one, AI brings cold, hard objectivity to tests that used to be totally subjective. Two, and this is crucial, it's a tool to help doctors, not replace them. Three, it can analyze enormous amounts of data to make better diagnoses and predictions. And four, the potential here is absolutely huge, but we've still got to solve real problems like cost and getting everyone on the same page. And that leaves us with one last big question to think about. We've just looked at how AI is transforming one very specific part of medicine. But as this tech gets smarter and smarter, almost by the day, what does that mean for human health as a whole? What new frontier is it going to unlock for us next?